Hey guys, I hope you're doing great today. This is our chapter number 44 in which we are going to discuss about YAML in Kubernetes. Guys, first of all, I would like to apologize for the delay in today's video. I was not feeling well for the last few days. That's why I couldn't upload a video lecture in our DevOps Roadmap playlist. So I apologize for that. Today we are going to talk about YAML in Kubernetes because we are going to deal with the YAML configuration files in Kubernetes a lot. Because we are going to create deployments, stateful sets, services, ingress, and pods using YAML configuration files. Now, what is YAML? So let's get started. And before getting started, make sure that you have subscribed DevOps Molvi on YouTube, and I really appreciate your support. So let's begin with YAML in Kubernetes. Guys, in order to understand the YAML, the core concept of YAML, why do we need YAML? I would like to share that example with you. We run disk free df command to know the disk usage on our Linux virtual machine. But when we run disk free command, df command, we get the values but not with any idea that the disk space is 1 2 3 4 5, and these are just random values 6 7 8 9 10. Okay, but we don't have MB or GB or KB, we don't know. So when we run df minus h hyphen h, and then the value can be 1.23 m or 2.2 g or 1.0 k. Okay, so what does this h switch mean? It converts, it makes these values in a human readable form so that we can easily read, so we can easily get to know how much disk space do we have on our Linux virtual machine, right? The purpose of sharing this example is that it is really hard for us if the data or the configuration files are not in human readable form. And that's what YAML does. That's what JSON also does. And that is actually the core purpose of YAML. It makes the configuration files human readable. So we can go through the YAML file and we can get to know that we have two stateful sets in this configuration file. We are going to deploy that many pods. We are going to deploy Nginx deployment. So that is the purpose of YAML. It makes it easy for DevOps engineers, for us, so that we can easily read out the configuration file. And guess what? We don't use YAML in Kubernetes alone. We also, if you remember, we have also used YAML in our Docker Compose lecture. Docker Compose dot, we have Docker Compose dot YAML, right? We have used YAML file in GitLab CI, and we have also used the YAML in our GitHub Action CI/CD pipeline, right? So YAML has a lot of importance in DevOps because YAML is the only language that makes it easy for us to go through the configuration files. We can create new configuration files using YAML language. So YAML stands for YAML. YAML stands for yet another markup and language. Okay, so that is actually the abbreviation of YAML, yet another markup language, or also it stands for YAML ain't markup language. YAML ain't markup language. This is also the the abbreviation of YAML. So YAML stands for yet another markup language, and it is an easy human readable friendly language. so that we can write configuration files in our DevOps routine jobs for DevOps tools like Kubernetes. We can also use YAML to write Docker Compose files. We can also use YAML configuration language to write our CI/CD pipelines using Circle CI, GitHub Actions, and GitLab CI. So YAML stands for yet another markup language, and the extension of all these YAML configuration files can be .yml, or it can be .yaml. It can be .yaml and it can be YAML.yaml. So guys, this is the general introduction of YAML. We have also gone through YAML configuration files while we had CI/CD lectures, and also we discussed YAML in our Docker Compose lecture. So now we need to understand that how we can write, or how we can easily understand a YAML configuration file in Kubernetes. Guys, there is really important to know that YAML is a syntax based language. Okay, so for instance, if I have this configuration file, for example, it is my cluster.yaml file. Okay, YAML. This is cluster.yaml file. So it contains a couple of data, metadata, and etc. So why it is a syntax based language? Because an extra space can cause your YAML file not to work. If I have extra space, or if I have any extra colon or semicolon, etc., so I have stronger chances that my YAML file, my YAML configuration file will not work. So extra spaces, extra semicolons, colons, or any other random configuration will not work in the YAML file. So that is why it is known as a syntax based language. We have to take care of our syntax, and guess what, we have, it is one of my favorite tool, and it is known as YAMLlint. YAMLlint. So if I write a YAML file myself, I can paste the content in YAMLlint. I can search, we will practically see, and this YAMLlint will tell us that this configuration file, this YAML file is 100% perfect. There are no extra spaces, there are no extra semicolons or colons or any extra configuration that is not needed in your YAML configuration file. So it is 100% okay. And if there are any issues, this YAMLlint tool will tell us that, man, you have to fix your YAML configuration file. It is having an issue on that line number or that line number. So that's why we must use YAMLlint tool, so that we can have a better idea that our configuration file does not have any issue. So that is why YAML is really sensitive, and it is a syntax based language. Now let's see what are the core components of a YAML file in Kubernetes. Guys, in order to make it simple, I will write a simple configuration file with its core components, so that it is easy for you to understand real quick. For instance, if I have this namespace .yaml, guys, and let me share a really great tip with you, that when we are writing configuration files in YAML for our Kubernetes cluster, it is a recommended practice that we must divide the YAML file into sections. If you don't understand it, let me explain. For instance, we have a namespace in our Kubernetes cluster. So we must have a separate namespace.yaml file. We have a service, and we must have service.yaml file. And if we have a stateful set, then we must have a StatefulSet sts.yaml file. If I have been using node port or cluster any other service, then it is a recommended practice that I can use node port.yaml. So these are a couple of examples, and when I have these YAML files in a single directory, it would be really easy for me to understand quickly what do I have in my Kubernetes cluster. Okay, I have this for my namespace, this for service, and this is for StatefulSet, and this is for my node port. So I can easily go through these YAML files and I quickly learn what do I have in my Kubernetes cluster, instead of having a whole and large YAML file. And it is possible that I have all of that content in a single YAML file, but it would be really hard, it would be difficult for me to understand, because that YAML file would get bigger and bigger and bigger. So it is a good and recommended practice that we must have separate configuration files. In the beginning, as a DevOps beginner, we must define, we must create, and that's what we are going to do in our lab. We are going to have different YAML files. Now, if I have this namespace.yaml file, then what do I have in this YAML file? So let's break it down, the core components of a Kubernetes YAML file. So most of the YAML configuration files in Kubernetes start with this API and API version. Okay, you will see it in all of our Kubernetes YAML file, and the version is v1. We are using the version 1 of our Kubernetes API. So API version v1, and after that kind, right under API version, kind. If I write kind here, this YAML will not work for me. That is why it is a syntax language. I have to take care a lot while I'm writing the configuration files of additional spaces, etc. And now, what is kind? What do we mean by kind? A kind can be a namespace, a kind can be a service, a kind can be deployment, a kind can be pod, a kind can be daemon set, a replica set, a service, etc. So all of these are kinds. Okay, now if I am going to write another YAML file for service that I will be writing in front of you, then the kind would be service, the kind would be StatefulSet, the kind would be node port. So now in my namespace.yaml file, my kind is namespace. I am going to define the namespace. Okay, and after that, metadata. And now, what do we mean by metadata? I have defined that my kind is namespace. So I have to share some additional details about my namespace, its name. Okay, so metadata can be name. If I want to share the name of my namespace, DevOps Elasticsearch. Okay, we are going to create an Elasticsearch cluster, DevOps Elasticsearch. Now this would be the name of my namespace. Alright guys, now you understand, this is how we write YAML configuration file. Now this is actually the simplest configuration file in YAML, and we have API version, we have kind, it is namespace, we can have kind as pod, we can have kind as deployment, and the metadata. Metadata means that if there is any additional information that you would like to share about your resource, and I have shared that the name of my namespace is DevOps Elasticsearch. Okay, so that's it. That is the example of a namespace YAML configuration file. So we are done with namespace.yaml file. If you have any questions, please write down in the comments and I will answer. Now we are going to write a sample configuration, YAML configuration file for our service. For instance, I am going to run Elasticsearch. This is for my Elasticsearch cluster, and I am going to define a service.yaml configuration. A service is actually the logical grouping of pods, and we define service so that our clients can access our pods. So I will modify this configuration file, and my kind would be now service. if I'm going to write any configuration file for pod, then the kind would be pod. For deployment, the kind would be deployment. I hope that you understand this concept. What is kind? And after that, guys, metadata. What is the name of this service? And also, we are going to add some more additional specs. SPEC, spec. So the metadata can be, I will write this as my ES service. So the name of my service is ES service. And also I will add that the namespace is DevOps Elasticsearch, the namespace that we have created earlier, DevOps Elasticsearch. And also if I want to add some labels, okay, I can add labels that this application is app is ES cluster. So this is my Elasticsearch cluster. So the name of the application is ES cluster. And now there is an important configuration that we have to add in this YAML configuration file. And it is actually spec, SPEC, specifications, or you can say that additional specifications, additional data about the service. And since we know that a service is a logical grouping of pods, that's why I will use spec, and I will write as selector that you have to use, or you have to select the pods from where? From this app. And then I will write as app colon ES cluster. Now this is the specification of this service, and it will select all the pods that are running under this label ES cluster. Since we know that a service is the logical grouping of pods, all the pods are grouped into a single service. Now I have used this selector so that it must know that it has to select all the pods that are running in this label. Okay, so every pod that is under this label is going to be selected. And now after that, I have to define the type of the port type, and the type can be node port, the type can be cluster IP, and the type can be load balancer, the type can be external name. So we have four types of service in Kubernetes. I'm going to use node port. Why? Because node port is used to expose the port of our service, Elasticsearch service, to my external user. Now after that, I have to define the internal and external port. The internal port where Elasticsearch runs on is 9200. I have to explicitly write all those ports for internal communication and also for external communication. So type would be node port. Why? Because I want my users to access my service using node port. Node port is actually a service type which allows our external users to access the service. Okay, similarly we have load balancer, we have cluster IP. So I will write the rest of the configuration here, and I will just add some ports. Okay, so we have a couple of types of ports here, and I have this port, for instance, this is 9200 for Elasticsearch, and I can define target port as 9200, and I can also define node port for my cluster as 31235, etc. So that's how, guys, we can define the ports. Okay, so this is an example of a service, and I have given the example of Elasticsearch which runs on port 92. Similarly, if I have service as Nginx, then I can use the port 80 here. Okay, I hope that, guys, now you understand. This is the API version, kind, as service. Earlier we had kind as namespace, metadata, name of our service, namespace, and also the labels, so that all the pods are under this label ES cluster of this service. And now we have to define further specification. This is more, we are going to modify, we are going to extend our YAML file, and we have added selector that all the pods in this label should be grouped together in this service. And after that, we are going to expose our service for our external user. That's why we are going to use the node port. And after that, for node port, we have defined some ports. This is the port for my Elasticsearch service, and I want all my traffic to be routed to this port 9200. That's why I have used target port. And finally, I have defined the node port as 31235 so that I can access this port on all my cluster nodes. So this is the example of a service.yaml file. And by the way, guys, I told you that I can define everything this in a separate node port.yaml configuration file as well. So instead of creating a separate file, I have defined all the specifications in this YAML configuration file. Now talking about the statefulset.yaml file. If I write sts.yaml file, the name of my file would be sts.yaml. Okay. Now my kind would be statefulset. Instead of service, instead of namespace, I will have statefulset. So this is the kind. The API version would be v1 stateful set, and we create stateful set for stateful applications. Okay, those applications that need persistent storage. And we can create daemon sets and replica sets for stateless applications that do not need any persistent storage. So that's why we have stateful set for those applications which are stateful, which needs a persistent storage. So for those applications which need persistent storage, we can define stateful set. And if these applications are stateless, then we can use replica sets or daemon sets. So the kind would be stateful set. And now for metadata, I will change from ES service to let's say that ES cluster. Namespace would be the same, DevOps Elasticsearch, and label would also be the same as ES cluster. Now we have to add some more specifications according to the stateful set. Okay, these specifications were regarding the service. Now we are going to change these specs as per our stateful set. So in stateful set, we can define containers. Okay, and now the name of the image which is used to build to run our containers. Okay, so I will write the image here, image, and the name of the image like my test image, my ES image. And since it is a stateful set, so we can mount the volumes as mount volume, data, etc. And also we can define mount path. So we can define the mount volumes, we can define the data and mount path. All of these are actually the requirements of a stateful set, since it needs a persistent storage. And one of the key important thing that I forgot, we have to define the number of replicas. Okay, my bad, number of replicas. If I define as 2 replicas, then it means that there would be 2 identical number of pods. And if I define as 3, we can change them later. And if I define 4, then there would be 4 pods in that. Then there would be 4 replicas. It means that there would be 4 pods, identical pods, and each pod will need a persistent storage, and each pod will use this image to run the container. So for storage, I have to define as volume claim templates. Okay, templates. And here I have to define the storage so that each stateful set should get that amount of storage. And storage class, like storage class can be standard, storage class standard. And also the disk usage request, I will, since it is volume claim, I will add request, and here I will define the storage as 5 GB. So if I have two replicas, it means that there would be two identical pods, and all those pods will get 5 GB of storage. And don't worry, we are going to practically execute these YAML files on our Minikube cluster. So we have replicas as 2. So it means that our 2 pods in that stateful set will have 5 GB of disk usage. So guys, this is a general example of a stateful set.yaml, which is a configuration file. And now I hope that you have a better understanding of how a YAML file in Kubernetes looks like. So we have API version, we have to define the kind can be namespace, kind can be pod, a stateful set, a replica set, deployment, service, node port. All of these are actually kind that we have to define. It is a must in our YAML file. And after that, the metadata, name of your kind, I have defined as ES cluster, the namespace, and also additional information like labels, app. And in stateful set, I have defined that my replicas, identical pods, should be 2. We can also upscale or downscale. We can upscale to 4 or 6 stateful set, and we can downscale by writing, by changing or modifying this YAML configuration. And after that, additional specifications like container and the image, Docker image, which is used to run that container. Okay. And also, since we have stateful set and Elasticsearch cluster and we need the data, so we have to define the mount path. Okay. It is similar that we defined in a Docker Compose or in a Docker container. So we have to define the mount path, and it is mount volumes and its path. And after that, volume claim types, it is actually PVC, persistent volume claims, and storage class is standard. We have the request for storage of 5 gigabyte, 5 GB. So we have actually 2 replicas. It means that each pod in that stateful set will get 5 GB of disk usage. So that was the example of the YAML file for a stateful set. We saw the example of namespace and service, and we can define a separate for node port, and we can have a separate YAML file for stateful set. So we have divided our whole Kubernetes cluster into small YAML, into separate YAML configurations. Now it is better for us to understand that we have a separate namespace YAML, we have a separate service, stateful set, and node port. So I would say that it is a good practice. So what do you think that if I had everything in a single main.yaml file? So if I had a main.yaml file, main.yaml, and I can define everything, namespace, metadata of stateful set, and also node port, and also service in whole in one main.yaml file as well. It is possible, but it would be for beginners, for DevOps engineers like us, it would be some sort of overwhelming, and also it would get a bit difficult to understand. So that is the practice, and I hope that you are going to follow. Now let's see our YAML files in action on our Minikube cluster. The lab begins. Alright guys, now you can see that I have opened my Kubernetes by DevOps Molvi GitHub repository. By the way, I have been sharing this link in every Kubernetes tutorial on my channel, so you can navigate to this folder. Okay, and it is my own cluster, Elasticsearch cluster. So I will click on it, and you can see there are a couple of YAML files. So first of all, if I open namespace.yaml, you will find each line with a brief explanation. For instance, now you can see API version specifies the API version. For the resource, kind is namespace, and metadata, the name of the namespace, which is DevOps Molvi Elasticsearch. All right. So similarly, I have another YAML for Elasticsearch service, okay, that we have already discussed. And now you can see we have the kind as service, API version, metadata, the name of the service, yes cluster, the name of the namespace, labels, and specification for the service. Okay, so you can see that I have this selector and app es cluster, and it matches pods with this label. Sorry, I have to zoom. Let me zoom it so that you can see it. Now I hope that you can see it. Specification for the service and selector and matches pods with this label, and this is the type of the service, node port. Okay, you can see it. And also I have defined all the ports: port 9200, target port, node port, the protocol, and the port number for external port for internal communication. Similarly, if I navigate to es main cluster.yaml file, where I have all the specifications for my stateful set and every information, every configuration that is required for a stateful set to create a two replica stateful set. Now you can see I have this API version, the kind is stateful set, and the metadata and namespace. Now guys, you have to make sure that every component of your Kubernetes cluster is within that namespace, and the namespace is DevOps Molvi Elasticsearch. So you can see that I have been using this namespace in my service.yaml file, and also in my namespace.yaml file, and also in the main cluster.yaml file. So every resource that I'm going to create would be in that namespace. So you have to make sure that you're using the correct namespace within your whole Kubernetes cluster configuration. This is really important. Now you can see the specifications for this stateful set, the service name that I have used here in esservice.yaml. It is the same as elastic es cluster, and replicas with number of pod replicas. Okay, 2. If I am using 3, then there would be 3 identical pods, and similarly for 4, for 6. And you can see the selector here where my app is es cluster, the same app that I have defined in the service.yaml file. And also I have other metadata regarding my stateful set, and the most important part is the container. Okay, the Docker container that I would be running and its image. So you can see the name of the container is es container, and image that it will pull, this is actually a custom image, and I have created this custom image with all the prerequisites, with all the pre-configurations. So I've been using this Elasticsearch container image for creating my own containers, and the resources that I have given to this container. And also you can see that I have used all the ports for the containers. Now these ports are actually for the container, and also the volume mounts where my volumes would be mounted into the container, and its mount path to mount the volume. Okay, and after that there are a couple of other configurations that are relevant to the Elasticsearch cluster, like the cluster name and the network host. So you don't have to worry about it, because I have explained each line with brief explanation, like this is cluster name and the name of the Elasticsearch cluster, this is the name, and also the network host binding and I have bound it to all the network interfaces. 0.0.0.0 mean that bind to all network interfaces, and this is actually the name of our Elasticsearch node, and also the value from delivered dynamically, and all the lines, all the configuration, each line is explained so that you have a better idea what's going on. So these are actually the values regarding my Elasticsearch cluster. Since it's a stateful set, I have to define the persistent storage for each pod. And you can see that I have volume claim templates here. And I have this metadata. And also I've told you that we are using the storage class as standard, and the each pod will get 5 GB of disk space. So I have defined the volume claim templates here, and now let me open, and I have pasted all the configuration YAML configurations here in my Elasticsearch cluster. So it is my mini cube Elasticsearch cluster. And guys, first of all, let me tell you that kube control get namespaces, and you can see that I don't have any namespace with DevOps Molvi Elasticsearch. So first of all, I will run kube control. Let me clear the screen. Kube control apply -f and namespace.yaml. And now you can see that my namespace has been created. Okay, so if I open this file namespace.yaml, I have copied all the file, all the content from my GitHub repository, and you just have to take the clone and you can run. These files are fully functional. You won't face any issues configuring your own Elasticsearch cluster with a stateful set of replicas as 2. Okay, and if I search again, I will run kube control get namespaces. Oh, sorry, get namespaces, and now I should see my new namespace as DevOps Molvi Elasticsearch, and it has been created and active 44 seconds ago. Right now, if I open ES service, and you can see I have this kind as service and name as Elasticsearch ES cluster, the namespace, and all the ports. So again, I will clear kube control get services -a all namespaces. So these are the services that have been created earlier when I initialized, when I run the minikube cluster. Now I will create my own Elasticsearch cluster service. So I will run kube control apply -f es service.yaml. All right, we have this service in my namespace DevOps Molvi Elasticsearch. So I will run kube control get svc. We can also run svc. It stands for service, and namespace name -n, and I will run DevOps Molvi Elasticsearch. And okay, we can see that our Elasticsearch cluster service with type as node port has been created, and it is running on these ports. Okay, all the ports information you can find it here. And after that, now I will run kube control get stateful set -a, and there are no resources. And if I run as DevOps Molvi Elasticsearch in namespace, there are no stateful sets in this namespace as well. So I will, first of all, let me show you what do I have in this ESSTS stateful set. It is actually ES main cluster. Okay, I have renamed it here, and you can see I have every information regarding my stateful set with volumes, etc. Everything is given here, and every line is explained briefly so that you can clear your concept. What is that line doing here? Okay, so first of all, by the way, kubectl get pv persistent volume -n DevOps Molvi Elasticsearch. There are no persistent volumes, and also there are no persistent volume claims in this namespace. Now, if I run this StatefulSet YAML configuration file, you will find here that we have created persistent volumes in that namespace. So let me run it. kubectl apply -f essts.yaml. All right, I have created my stateful set in this service. All right, now if I check kubectl get stateful set -n DevOps Molvi Elasticsearch, and I should be able to see that I have created this stateful set with two pods, and they're actually in the initialization phase, and it will take a couple of moments. And if I run kubectl get pods -n DevOps Molvi Elasticsearch, now you will find that my pods should be in the initialization state. Okay, now you must be surprised or thinking that from where I got this name and naming convention, etc. So I have already shared it here. That's why it is really important to understand the YAML. I have this name here. Okay, so these are the values. All the values have been given here, and I have these pod names accordingly. Okay, now you can find the difference that pod is initializing. Since it is downloading, it is pulling, the container is pulling the image, so that's why it takes a bit time. Okay, you don't have to worry. And now we are in the pod initialization phase. All right guys, finally my pods are now running, and you can see that after the initialization phase has been completed, now the pods are running. I'm sorry, you know that internet service is a bit sluggish in here in Pakistan, so that's why it took a little while. It took a little more time pulling images and then running my pods. Okay, now you can see that I have two pods. Okay, because the stateful set has two replicas. And guys, if you're worried about the kubectl commands, you know that I have already shared two lectures with you covering around 80 plus kubectl commands. So I have these commands here on my GitHub repository. So if you want to know how I can see the number of pods, or if I want to update the number of replicas and how I can roll out changes, I've already shared all these commands about stateful sets, rolling out changes, deleting pods, and you can see kubectl rollout status ES cluster. So you can follow this document and you can learn all these kubectl commands. So finally my stateful set is running, and I can also get into any pod. For instance, if I want to SSH, I want to connect with any pod, then I can run kubectl exec. Make sure that you remember all the commands. Okay, it's a good practice. And -it interactive and the name of the pod. Okay, ES cluster 0 and -n namespace name DevOps Molvi Elasticsearch, and the command that I would use to enter into the pod. Okay, bin bash. All right, I am in the pod ES cluster 0. Okay, and similarly, if I want to see that if my Elasticsearch is running or not, I can run curl localhost, and the port is 9200. Make sure that you remember it. 9200 colon 9200, and you can see that my Elasticsearch is running. Similarly, if I want to see the Elasticsearch on my another pod, which is Elasticsearch ES cluster -1, okay, and I am in, now you can see that I am in ES cluster -1 or -1, which is my second replica, second pod in my stateful set. And I can see curl localhost colon 9200, and Elasticsearch should be running here as well. And you guys know that this is the mount path. Okay, so that was about the stateful set. And if I exit, you can run all these YAML files, you can execute. You must run these YAML files. You must learn the structure of YAML in Kubernetes cluster. So I have shared everything, every detail that has been possible for me in all these YAML files. And if you want to, if you are facing any confusion, you just see the comment. Okay, I have commented out each line one by one, and you can find brief description of each line in each YAML configuration. So I hope that it would be a big help for you to learn the YAML in Kubernetes. And it is a must to learn about YAML, because you are going to configure, you are going to build your Kubernetes cluster and the infrastructure like pods, deployments, replica sets, daemon sets, stateful sets in a Kubernetes cluster in your DevOps engineering position. So that is why, guys, I have tried my best to share each and every possible detail. And also, guys, I have tried my best to teach you the YAML line by line. Okay, I hope that you will like this lecture, and if so, make sure that you subscribe DevOps Molvi on YouTube and appreciate and support my channel. In the next lecture, we are going to have a quick discussion on the difference between daemon sets, replica sets, and stateful sets. It is also one of the important concepts and one of the best lectures that you will have on DevOps Molvi YouTube channel. I will see you in the next lecture. And once again, my apologies for being a little late in uploading this video. I will see you in the next video. Have a good one, and bye.